All right, before we get started, we always love to do a Green Home Institute membership spotlight. And this time we've got not one, but two GHI members working together, Architectural Resource and Harvey and Kay Bell. Their home, called A Pleasant Future Vision in Birmingham, Michigan, was recognized as America's first CEUS 0 2021 design certified home, now has received full and final Passive House US certification. The home features a -20 on the HERS Index and a -22 on the new Carbon Index, making it a net positive home, or a home that gives more energy than it takes. We'll be featuring a full home tour on this project, which includes additional sustainable features beyond just energy. So stay tuned, and you can check out architecturalresource.com to have them help you assist on your next project. And this is who Green Home Institute members are. This is what Green Home Institute members do. So can you. Go to our website, greenhomeinstitute.org, and please become a member. Before we get started, also a huge thanks to our platinum sponsor for 2024, Rheem. They have heat pump water heaters, which are the future of water heating. They take natural heat out of the air and use it to heat water with zero emissions, directly up to 400% energy efficiency. Rheem offers hybrid water heaters with backup resistant 240 volt to ensure hot water flowing all the time, and 120 volt systems, just plug and play, that quickly replace old gas systems with many times without the expensive electrical upgrades. Now, the Inflation Reduction Tax Credit benefits are up to $2,000 for these Rheem heat pump water heaters, and another $600 may be available back to make the electrical infrastructure upgrades that you might need. Now, if you're not a fan of heat pumps, you're in a small, tight, multifamily apartment, you're concerned about the noise, I don't care. Sure enough, they also have just your traditional tank electric water heater, which does have the time of use demand response programming that is available as well. Check them out over at rheemheatpumpwaterheaters.com today. All right, well, welcome everyone to All About the Energy Rating Index, or ERI. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I'll be your moderator. My name is Brett Little. I'm the education manager here. This course is approved for multiple continuing education units, including the Certified Green Home Professional under Energy designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Make sure to grab that CEUS, Certified Passive House Consultant, code at the end to check it out. So I am super excited to have our speaker on today. Eric Straight is going to be talking to us about the Energy Rating Index and what it all means, and what ways you can get involved to make more informed decisions on your project. So Eric, I'm really glad to have you here, and please take it away.
Thanks a lot, Brett. Thanks for hosting this and for having me here. All right. So as Brett mentioned, today we're going to be talking about the Energy Rating Index. I think the title of the webinar, All About the Energy Rating Index, was a little bit ambitious. In the hour that we have, we'll hopefully scratch the surface and give you a better understanding of what it is. So what we're going to do first, I'm going to briefly introduce myself, and then hopefully by the end of this, you'll be able to give reasonable high-level answers to the following 5 questions. What is the Energy Rating Index? How is it calculated? Again, at a high level, not looking formula by formula, but just basic understanding of the calculation. What are its applications? Where can you find ERI resources? And how can you utilize those resources to inform your decisions as a builder or contractor or an energy rater? So about me, I graduated from Arizona State University in 2016. I had no background in energy efficiency or construction. I majored in math and econ, minored in statistics. But a couple months before graduating, my now wife and I decided we wanted to move to Denver. So I took a temporary job with Residential Science Resources, otherwise known as RSR. That turned into a permanent gig, and I've been working here now for 7 years. RSR does implementation contracting for utility energy efficiency programs, primarily in the residential new construction segment of the market. So we work with utilities to design programs to meet their goals, analyze those programs to make sure they're achieving their desired outcomes, and then also the day-to-day administration of those programs. A couple of years after I started with RSR, I also started doing some work for our sister company, HouseRater, which is a software company. It started out as an internal tool for two things: field data collection for energy ratings, and as an intake tool for our utility programs, a sort of online portal for submitting verification documents that we required for our programs. It's evolved over the years, and a few years ago we partnered with Building Science Institute, a home certification organization, which is a term I'll cover here shortly, as their software tool for Energy Star and Zero Energy Ready homes modeling and oversight. We are an EPA and DOE approved software for the calculation of Energy Star and Zero Energy Ready home ERIs, two other things I'll be covering later in this presentation. So now that the introduction is out of the way, let's look at what the Energy Rating Index is. So when I refer to the Energy Rating Index, I'm referring to the ERI defined in the standard you see here, ANSI RESNET ICC 301. You'll notice in the last line of the standard, of the title of the standard, it says using an Energy Rating Index. Energy Rating Index is not a trademarked or proprietary term, so someone could create their own Energy Rating Index tomorrow if they wanted to. But in my experience, when I refer to it, this is the standard that people currently mean when they talk about an Energy Rating Index. So this is a public standard that was developed and released by the Residential Energy Services Network, known as RESNET, in 2014, based on their HERS Index. The HERS Index is RESNET's trademarked Energy Rating Index based on the 301 standard, but it is modified through their min-HERS standard. It is a continuous maintenance standard, meaning that addenda are proposed and approved and implemented between version updates. Version updates are currently on about a 3 to 5 year cycle, and those version updates incorporate the approved addenda from the previous versions. So the one we're looking at here, the 301 2019, incorporated all the approved addenda to the previous version, the 301 2014. And we will talk about the different versions of the 301 standard a little bit later. So the definition I have here for the Energy Rating Index is straight from the 301 standard. The Energy Rating Index is a numerical integer value that represents the relative energy use of a rated home as compared with the energy use of the energy rating reference home, where an index value of 100 represents the energy use of the energy rating reference home, and an index value of 0 represents a home that uses 0 net purchased energy annually. So if a home has an ERI of 100, that means its energy efficiency is equal to the energy efficiency of the reference home it's being compared to. 1 point represents a 1% change in the energy efficiency compared to the reference home. So if a home has an ERI of 50, that means it is, based on this specific calculation, 50% more energy efficient than the reference home it's being compared to. And like golf, lower score is better with the ERI. As I just mentioned, a home with an ERI of 50 is 50% more energy efficient than the same home with an ERI of 100. So we're talking about reference homes. I thought it might be helpful for some people to define what a reference home is. So a reference home is a modified version of the rated home or the as-built home to compare energy efficiency against. So it's like a baseline. They modify certain features of the rated home and analyze that to get the energy efficiency of that baseline home and compare the two. The 301 ERI reference home is based on the 2006 IECC, and the reference home specifications are in section 4.2 of the 301 standard. I'm not going to go over all of them. There are a lot, but that's where you can find how they modify the rated home for the comparison home. And the reference home is a geometric twin of the rated home, meaning that all the geometries are the same, has the same conditioned floor area, the same volume. So you're comparing differences in the assemblies and the equipment and appliances, things like that, for that baseline. So what is the scope of the 301? What does it define? First, it tells you how to calculate standard energy use for an energy rating index, how to use that energy use to determine the energy rating index of a home, how to determine the CO2 index. And this particular part of the scope is version dependent. Not every version, older versions didn't have the CO2 index. It's relatively new in the past couple of years. It defines the minimum rated features, which are the characteristics of the building elements, which are the basis for the calculation of end-use loads and energy consumption for the purpose of an energy rating. So these are the things that inspectors have to go out in the field and verify characteristics of the home to generate an accurate energy rating index. 5 and 6, I don't know how widely these are used. As I said, my kind of background is more in the new construction area, but it does tell you how to calculate the retrofit savings for existing units and the cost effectiveness of energy saving improvements. And finally, the labeling requirements for the certified energy and CO2 performance of a rated home. So now that we know what the ERI is, we're going to take a look at how it is calculated. So this is the high-level formula for calculating the ERI. There are hundreds of formulas that go into the terms in this formula that we're not going to go over, but this is kind of the last one that gives you your energy rating index. So that first term, the PE fraction, is the total energy use minus on-site power production divided by total energy use. So this is what modifies the energy rating index or lowers the energy rating index when there's on-site power production. And also allows the energy rating index to go negative. In the introduction, Brett showed that passive house that had a HERS of -20, the way it does that is with on-site power production, obviously. If there is no on-site power production, then that formula becomes total energy use minus 0 divided by total energy use. So it's 1, so it doesn't modify the energy rating index at all. The second term is the total normalized modified load of the rated home. So that's the sum of the normalized modified end-use loads for heating, cooling, and water heating, plus the end-use loads for lights and appliances. And we'll go into what normalized and modified mean in just a minute here. Total reference home loads, that's the sum of the reference home end-use loads for heating, cooling, water heating, and lights and appliances. And then there's an index adjustment factor that's based on the square footage and the number of bedrooms for the rated home, and that's all multiplied by 100, which is what makes this an index. So the important thing here, the reason I show this formula is to understand that the ERI uses normalized modified loads, not just energy use in determining the energy rating index. So the reason for that is because they wanted to remain fuel neutral, because they didn't want stakeholders making decisions just to gain the index score. If you use another method for calculating an energy index, such as site energy or source energy or emissions costs or fuel costs, depending on which one you use, it makes either gas or electric look better and have lower index scores than the other. So again, they didn't want people gaming the system by doing that. So by using end-use loads, they make it so that they can kind of be fuel neutral. So a load is the quantity of heat that must be added or removed from the building or hot water tank to meet the desired temperatures. And energy use is the quantity of fuel required by the equipment to satisfy that load. So what they do instead of using energy use is they modify the load. So they divide the load by the equipment energy efficiency rating. So if you have a piece of equipment that is twice as efficient, the load's going to get cut in half, essentially. And again, this is to remain fuel neutral. So that is what the ERI uses, loads, not energy use, and they modify those loads. The normalized part is a little more complicated. We're not going to go into that too much. That is accounting for the energy efficiency improvement potential of different fuel types and systems. So now we're going to look at the different versions of the 301. The first version was ANSI RESNET 301-2014. It was approved in December 2020 and published in March of 2014. Originally, the name was the standard for the calculation and labeling of the energy performance of low-rise residential buildings using the HERS Index. They did modify that in 2015 to remove HERS Index and replace it with Energy Rating Index. And then replaced all references to HERS, to the HERS Index in the standard with the Energy Rating Index. And they did this to get the sponsorship of the ICC as a public standard. They couldn't have a trademark term in the standard for other people to be able to use it. So they dropped that and replaced it with the Energy Rating Index. These are the different addenda that were approved to the 301-2014 over the years until the next version, the 301-2019. I've highlighted a couple here that are relevant on a future slide in the ERI applications. But you can see there were a lot of addenda that modified this over the years. The next version was the 301-2019. The name changed here to the standard for the calculation and labeling of the energy performance of dwelling and sleeping units using an Energy Rating Index. In the 301-2014, it was only applicable to, I believe, buildings that were 3 or 4 stories or lower. With the 301-2019, they changed that so that the height of the building didn't matter. You could rate individual sleeping and dwelling units regardless of the number of stories. This is the current version that's used with addenda A, B, C, and D. So this is what people are using for the different applications of Energy Stars, Energy Ready, other things we're going to cover here. And again, these are the addenda. I've highlighted a relevant one that we'll discuss later. And finally, the 301-2022 is out, but it's not currently being used yet. At some point that will replace the 301-2019. And as I mentioned, the new versions incorporate all the addenda from the previous version. So the 301-2022 will have everything from the 301-2019 and addendas A through D. All right, so what are different applications of the ERI? First is just standalone. There are a few reasons that people might get an ERI just to get an ERI, not for any specific certification. The first is utility program participation. Many utility programs require an energy rating index because of the oversight they bring. When you get an energy rating index, you're subject to some type of QA and oversight requirements that otherwise the person might not be. And the utilities like to have that kind of verification. The second reason is energy efficient mortgages. Many lenders offer what are called EEMs that account for utility bill savings when considering what mortgage payment a home buyer can afford. EEMs for new homes typically require an ERI to determine those utility savings. So the idea here being that if a bank determines that you can afford a $2,000 a month mortgage and you buy a house that your utility bills would be 100 versus a comparable house where they'd be 200, you have an extra $100 a month that you can put towards that mortgage versus the home with higher utility bills. And finally, for builder marketing, there are a lot of builders out there that want to get an ERI just for marketing reasons. They tell potential home buyers, this is the verified efficiency of the home you're buying. This is the estimated energy uses and utility bills and things like that. So a lot of builders like that marketing material that they can provide to the home buyers. The next application is code compliance. The ERI was first added as a code compliance pathway in the 2015 IACC. The reason it didn't exist before, as I mentioned, the first version of the ERI standard was the 301-2014. So in previous versions, there wasn't a public standard available for code. One thing about the 2015 is it doesn't specify the reference standard in Chapter 6 of the residential section of the code. So the 301-2014 without any addenda was in effect when the 2015 IACC was published, but there is some debate out there about which version of the 301 standard to use since it doesn't say which one for code. in my opinion, and from talks I've had with people smarter than I am, I believe the 301 2014 without any addenda is the correct version to use for the 2015. The 2018 IECC uses the 301 2014 republished in 2016. So that's the 301 2014 with addenda A and B. And that one is specified in the referenced code section of the standard of the 2018 IECC. And the 2021 IECC uses the 301 2019. It doesn't specify any addenda, but addenda A and B were approved when the 2021 IECC was published. So I think that's the one that is commonly used for the 2021 IECC ERI. One thing about the IECC ERI is it does modify one part of the 301 standard, that being the mechanical ventilation of the energy rating reference home. So it replaces the formula in the 301 standard for the energy rating reference design ventilation with this formula here. The ventilation rate in CFM is 0.01 times the total square footage of the house plus 7.5 times the number of bedrooms plus 1. So it's not a standard off-the-shelf 301. It is modified by this formula. Brett, do we have questions?
Well, yeah, I think the question is then, if I understand right, typically the codes are based off of, the ventilation codes are based off of ASHRAE 62.2, or a lot of states will, they'll take that information and then they'll remove ASHRAE and call it their own code, I guess, for whatever reason. Is that higher, lower? How does that compare, just relatively speaking?
That is a good question. I believe it is higher. So because the 301 reference zone was based on the 2006 IECC, ventilation standards have increased since then. So I believe this would be a higher ventilation rate requirement than the standard 301.
Okay. And well, since I'm here on, and did you have any more to add on codes at all?
A little bit about on-site, but
well, yeah. So, when ERI is used, the energy rating index is used for code. Do you typically find that that is the sole way that energy efficiency is identified for the home, or do you also see that the code officials are still going out and doing additional evaluations prescriptively on their own accord, maybe sometimes conflicting with ERI? I mean, what have you heard or seen out there?
So in my experience, the ERI as a code pathway isn't commonly used. It's still not very popular. It does specify that there are mandatory requirements from the prescriptive part of the code that also have to be met. So it's not just doing the ERI and meeting the performance requirements. You do have to meet other prescriptive requirements specified in the code in addition to the performance requirements.
Mm-hmm. And do you know any reason why you don't see it typically adopted?
So in 2015, the targets specified in the code were pretty aggressive when they first came out. So it was a bit of a jump from the other compliance pathways. In 2018, they relaxed those targets. So it became more feasible. And I actually do have a piece in here about a study that was done and the ERI being a viable pathway for 2018.
Oh, great. Yeah.
But I think that's kind of why. One, two, just the requirements. It's probably more expensive for builders to get the ERI because it has to be registered and the raters have to pay registration fees and things like that, versus doing a purely prescriptive or UA or performance total building performance pathway for code compliance.
All right. Thank you.
Yeah, of course. All right, so on-site renewable energy, it's not mentioned in the 2015 IECC, so it can be used to meet the performance target. In 2018, they do mention it, but if it's used to meet the target, you must meet the prescriptive R values and U factors of the 2015 IECC. Normally for the ERI pathway, if you're not using on-site power production, you still have to meet 2009 IECC installation backstop, but that gets more stringent if you are using on-site power production. You got to meet the 2015. insulation backstop. And in 2021, if you use PV to beat the target, you must meet the prescriptive R values and U factors, again, from the 2015 IECC. If you're not using it, the UA of the home must be 115% or less of the 2020-21 UA. Again, if you're not using on-site power production.
And just to clarify, you're talking about the efficiency of the walls, correct?
Yeah, all the envelope assemblies, walls, ceilings, foundation walls, rim joists, frame floors, windows, doors.
Thank you.
Yeah, and for anyone who doesn't know, UA is the U factor times the area. So what you do for a home is you take the effective R value, the inverse of that is the U factor, multiply that by the area of each assembly, your walls, your ceilings, your joists, as I mentioned, windows, all that, and then add those up. And then you compare that to if those assemblies were built with the code specified U factors. The code has a U factor table that says for given assembly types, this is in climate zones, this is the U factor you use. So you take that code U factor, multiply it by the same area as the as-built home, add those up and compare the two. And the as-built home has to be lower than the code specified UA value. So as I mentioned to Brett's question, the ERI pathway is not currently very commonly used for code compliance. So the National Association of State Energy Offices performed a field study of over 120 houses across the state of Colorado in 2020, and of those, 31 used the prescriptive pathway, 6 used the UA pathway, and 91 used the total building performance, 0 used the ERI. But what they found in their analysis was that the average ERI across those homes was a 58. The ERI target for Climate Zone 5, where they did most of this work, for the 2018 IECC is 61, which means that the average house was passing by 3 ERI points if they would have used that pathway. And 3 points is pretty significant. So it's possible that builders could save money by looking at the ERI pathway and analyzing different ways to meet the ERI target instead of just looking at the other pathways, the total building performance, prescriptive, or UA. So the next ERI application, sorry,
Eric, real quick, there was a great question here because I think maybe I missed. I mean, I think I know the answer, but I might have misheard you say it at the beginning. Someone asked, "Are we talking about something that can be applied to residential?" And so that's why we're all here today. We're the Green Home Institute, so absolutely we're talking about residential. But can you clarify where the cutoff is between ERI and then maybe where ASHRAE 90.1 starts to get involved, right? Like how high can we really go? How big as far as units, multifamily, single family? Maybe I missed you saying that.
So I don't believe there's a limit on the number of units or the building size, but I believe you can only rate the individual units. You can't rate like the building as a whole,
right.
Common spaces, things like that. It's just the individual dwelling or sleeping units that they can get rated. But yes, with the from 301 2019 on, building height doesn't matter, number of units doesn't matter.
Great. Thank you for clarifying that.
Yep. So Energy Star. Energy Star has to be overseen by an EPA-approved home certification organization, otherwise known as an HCO, which the EPA defines as independent organizations recognized by the EPA to implement Energy Star certification program when an energy rating index or dwelling unit modeling compliance path is used. Energy rating companies are providing third-party verification for these compliance paths are required to operate under an HCO. So there are currently 2 home certification organizations that are EPA recognized, Building Science Institute, otherwise known as BSI, and RESNET. There is an open application process. They opened it up a few years ago. So anyone can apply, but they do have, it's pretty stringent, the requirements. You have to be able to have the oversight, have the software tool, have everything you need to certify Energy Star homes. The current 301 version is used to determine performance compliance for the ERI. So as I mentioned, the current version is the 301 2019 with addenda A through D. As new versions get adopted, Energy Star performance calculations switch over to those newer versions. What it does is the rated home gets analyzed against the 301 reference home to generate an ERI for the rated home. And then the Energy Star reference home that's specified in their National ERI Target Procedure document, which varies based on the Energy Star version. As the Energy Star versions go up, the reference home gets more stringent. So that reference home with those specifications is analyzed against the 301 reference home to determine the Energy Star reference home ERI, which is the Energy Star target ERI. So the rated home ERI gets compared against the target ERI, and it has to be equal to or less than to meet this performance requirement. And it's passing if the rated home ERI without on-site power production. That's an important distinction. Energy Star ERIs don't consider on-site power production, is less than or equal to the Energy Star reference home ERI. And just because it meets the performance ERI requirement, there are still other mandatory prescriptive requirements it has to meet to get Energy Star. This is just one of those requirements. The next application is Zero Energy Ready Homes. ZERH is overseen by DOE recognized Zero Energy Ready Home certification organizations like the EPA and home certification organizations, which, to quote DOE, implement and maintain the integrity of the Zero Energy Ready Home certification process. This includes certification, administration of documentation, quality assurance, and education and training of raters. And again, there are two DOE ZERH certification organizations that are recognized, the same two as the EPA, Building Science Institute, and RESNET. Again, the current version of the 301 is used to determine performance compliance. There is a prescriptive path available in version 1. In the version 1.x. I don't know if it's still there for version 2, but whichever path you take for Zero Energy Ready does require Energy Star certification, which does require an ERI and performance. So regardless, you're going to have to do an ERI to get Zero Energy Ready, whichever path you take. Again, the rated home is analyzed against the 301 reference home, and then the Zero Energy Ready Home reference home that are specified in Exhibit 2 of the Zero Energy Ready Home National Program requirements. And again, this varies based on Zero Energy Ready Home's version. Version 2 is more stringent than version 1. Is analyzed against the 301 reference home to determine the Zero Energy Ready Home target ERI. Typically, the Zero Energy Ready Home reference home is more stringent than the Energy Star reference home, so the targets are lower. And again, it's passing if the rated home ERI without on-site power production is less than or equal to the Zero Energy Ready Home reference home ERI. There is one caveat here. Every version of the ERI has to be a little different. Again, it still has to meet the mandatory prescriptive requirements of the program. On-site power production for Zero Energy Ready can be used to lower the ERI up to the number of points the target ERI is reduced by the size modification factor. So the Zero Energy Ready Home has some benchmark sizes based on the number of bedrooms for that gives you a given number of square feet, and it compares that to the actual home, and then it will modify the target down if the actual home is larger than the benchmark for the number of bedrooms. And what this is saying is that if that target ERI gets lowered because of this size adjustment factor, on-site power production can be used to lower the rated home ERI an equivalent number of points. So if the size adjustment factor lowers the target by 2 ERI points, on-site power production can be used to lower the rated home ERI by 2 energy rating index points. So next, the 45L builder tax credit, as a lot of you are probably aware. This was renewed, I believe, in 2022, retroactively, but they changed the requirements. Before, it was tied to energy savings compared to some code year or something. They changed that. They changed it to a tiered system with 2 certification levels and rebates or credits available. I'm going to look at single family. Multifamily is a little more complicated, but this will give you an idea of the 45L builder tax credits that are available. So the first tier is for Energy Star certification, and that is $2,500. Version 3.1 of Energy Star is the required version for homes permitted before January 1st of next year. And then on or after January 1st of next year, version 3.2 of Energy Star single family is going to be the standard that will have to be met to get $2,500. The next tier is Zero Energy Ready Homes, and that is a $5,000 credit. It's on version 1.8 for homes permitted before January 1st of this year. For homes permitted on or after January 1st of this year, it's version 2.0. This creates kind of an interesting scenario. I'm going to be interested to see how many homes go for Zero Energy Ready that are permitted between January 1st of this year and January 1st of next year, because version 2 requires Energy Star version 3.2 certification, which is quite a bit more stringent than version 3.1. So a builder could go for 3.1 for $2,500, or have to attain version 3.2 and Zero Energy Ready Homes version 2 for $5,000. So it's kind of an interesting situation where the versions aren't quite lined up for this year. All right, so what ERI resources are available? Here's a list of links to the different applications of the ERI that I mentioned. I won't go into them too much. You can follow them if you want to learn more about these. One that I didn't mention was LEAD. I believe the current version of, I'm not very familiar with the LEAD program. You all are probably way more familiar than I am, but I believe the current version is 4.1, and that requires Energy Star version 3 ERI. So that is another use of the ERI. I'm just not very familiar with it. But I did put a link up there to the LEAD program. Home certification organizations and ZERH certification organizations. They handle the training, certification of energy modelers and inspectors. As I mentioned, there are two out there, Building Science Institute and RESNET. I have links to those here. And finally, approved software. So House Rater, company I work for, is EPA and DOE approved through BSI. And then ResNet has 3 approved softwares: RemRate, Ecotrope, and Energy Gauge. I provided links to all of those here as well. The National Renewable Energy Laboratory, NREL, manages a tool called Open Studio ERI. It's an open source project that allows calculating an energy rating index using the DOE's Open Studio Energy Plus simulation platform with an HPXML file. So this is actually what House Rater uses. We have an API to this where we pass our models to be analyzed by Energy Plus. It supports 301, standard 301 ERIs, IECC ERIs for 2015, 2018, 2021, Energy Star ERIs, and Zero Energy Ready Home ERIs. As I said, it's open source, so anyone can access it. Anyone can download it and modify the code as they desire. It's a really cool resource that's out there. Using it without a user interface like our softwares is difficult, to say the least. But if someone has the desire to go out and build a user interface and be able to do this themselves, it's out there and they can do that. All right, so how do you apply these resources? First of all, energy raters are an amazing resource for builders, contractors, everything. They can provide design assistance if you're developing a new project and you want it to meet a certain standard, whether it's for 45L, Energy Star, and anything else. They can help you with that to make sure that your plans are going to meet those, do plan reviews and make sure they're going to meet the requirements. They can provide training to installation HVAC contractors. You know, one of the parts of an energy rating index, one of the minimum rated features, is verifying installation quality, and it's an issue. There are a lot of contractors out there that aren't doing a great job, and that definitely affects the energy efficiency of the home. It affects the ERI. It affects whether or not the home can meet Energy Star. So energy raters are a great resource for training installation contractors on what it needs to be. In HVAC contractors, another common issue that's seen that affects ERIs is duct leakage. Working with your builders to identify contractors that are underperforming and then maybe helping offer trainings, things like that, to get them up to speed. And then air sealing is another big one as well. And then finally, software scenario modeling. Energy raters have access to energy rating software. That's how they do their job. So they can help you identify, again, what improvements need to be made to meet a certain target. So that brings us to the approved softwares. You can do incremental capital cost analysis to achieve a desired certification. So you can test various individual or combination changes to a baseline house to see how they affect the rated and or target ERIs. If you're trying to meet Energy Star for the 45L or Zero Energy Ready or something like that, and you're not sure the best way to get there, you run some different scenarios, you figure out the cost of those individual combination changes, and then determine the most cost-effective ways to get to those energy efficiency goals. You can also do fuel usage and cost comparisons to optimize utility costs for homeowners and homebuyers. All the softwares, when they run these analyses, they return fuel usage information for the rated and the reference home, so that you can see how different changes affect that fuel usage. And finally, you can do emissions comparisons for ESG reporting. Again, when you run an ERI, you get emissions information back. It tells you the carbon dioxide in tons per year, sulfur dioxide, nitrogen oxide, all that information for whatever you might want to use that for. All right, so I went ahead and ran through an analysis example where I took a baseline home, the specs of which are listed here, and did some individual modification and combination modifications to see how it would affect this home's ERI. So this baseline home is 3,121 square feet, 30,245 cubic feet. It has 4 bedrooms, 3 floors, 2 of which are above grade, and the foundation is a conditioned basement. The envelope has R11 foundation walls, an uninsulated slab, R50 frame floors, R21 above grade walls, R50 ceiling, R5 doors, 0.34 U-factor SHGC windows, and the infiltration is 3 ACH50. The ducts are all in conditioned space. It has a 92 AFUE gas furnace, 13 SEER AC, 0.69 EF gas water heater. The ventilation is 81 CFM, 30 watt CFM per CFM, continuous fan. And the duct leakage outside is 4 CFM 25 per 100 square feet. And for lights and appliances, the dishwasher or the clothes washer is 400 kilowatt hours per year, and 1 IMEF. The dryer is 3.01 CEF, 467 kilowatt hours per year for the dishwasher, 709 kilowatt hours per year for the fridge, and 65% CFL, 35% incandescent lighting. So this is the baseline home. It has an energy rating index of 71. The Energy Star version 3.1 target was 65. Zero Energy Ready Homes version 1.8 was 63. So it is not meeting Energy Star or Zero Energy Ready Homes. The first change that I did was I replaced the lighting from 65% CFL, 35 incandescent to 100% LED. And you can see that change alone got the ERI to 69. Still not meeting the targets, but that's one change. The next change I did, and again, this was just to the baseline. So I set the home back to the lighting from the baseline and just changed the clothes washer. So I put an Energy Star clothes washer instead of the default. And again, that dropped the ERI 2 points, but not meeting the target. Next, I replaced the clothes dryer with an Energy Star clothes dryer, and that dropped the ERI 1 point. Then I looked at the dishwasher, threw an Energy Star dishwasher, again, dropped the ERI 1 point. Energy Star fridge, dropped the ERI 1 point. And then I went ahead and combined all the lights, the lighting upgrades and the appliance upgrades into one, and updating all of them, dropped the ERI from 71 to a 65, which is meeting the Energy Star version 3.1 target. Still not meeting Zero Energy Ready Homes version 1.8, but it did come down quite a bit with all those changes combined. Then back to the baseline, I switched the gas furnace and AC out for an air source heat pump that was 9.5 HSPF and 16 SEER. And that dropped the ERI 3 points, but it increased the Energy Star version 3.1 target and decreased the Zero Energy Ready Homes target. The reason for that is that, as I mentioned with Energy Star and Zero Energy Ready Homes, the reference home is specified in their documentation. So they have for an air source heat pump given efficiencies, and apparently in Energy Star it's a little bit worse. So the air source heat pump it increases the target, and in Zero Energy Ready it's a little bit better. So you don't see as much savings, or you see more savings in the reference home when you switch to an air source heat pump versus a natural gas furnace. So the target goes down a little bit. So some interesting effects that you can come across when you start switching equipment types. Then we looked at a tankless gas water heater, and this dropped the ERI 5 points, which I was pretty surprised about. Didn't change the targets for either Energy Star or Zero Energy Ready, but this seems like a pretty good bang for the buck improvement. Then I threw in a heat pump water heater, and again, because the changes in the reference home and what it does with the equipment, the ERI came down 3 points, but the Energy Star target went up 1, and the Zero Energy Ready Homes target went down 2. So depending on what you're trying to meet, that's something you have to look at when you're switching equipment. Then I tried 0.30, 0.30 U-factor SHGC windows. Didn't change the ERI or either of the targets. And same, infiltration, I went down to 2 ACH50 from 3 ACH50, and that didn't change the ERI target here. One thing or the ERI, with the ERI, you get back, when you run the analysis in the software, the result the software gets back is a decimal. So it is likely that this lowered the ERI somewhat, but say before it was a 71.49, that gets rounded down to a 71. If it goes down to a 70.5, that's going to get rounded up to a 71. So even though it's, there's a 0.99 difference there, so this likely did lower the ERI, but not enough to reach that threshold where it gets rounded down to 70. And then we looked at leakage outside, 2 CFM 25 per 100 square feet from 4, and that lowered the ERI by a point. Then we threw R5 continuous insulation on the walls in addition to the R21 cavity, and that dropped the ERI by 2 points. Up to ceiling insulation from R50 to R60, that did not change the ERI. And then I threw all the changes into one. So everything we talked about here, all the lights, the appliances, the mechanicals, the insulation, everything. And that dropped the ERI from 71 to a 55. And now it is exceeding the Energy Star version 3.1 target and the Zero Energy Ready Homes version 1.8 target pretty significantly. So didn't need all those changes to get there, but just to give you an idea of what you can see. So putting it all together, the cells highlighted green were meeting either Energy Star and or Zero Energy Ready. The ones in red didn't change the ERI, so they had a minimal effect. So windows infiltration, ceiling insulation all had no effect. All the lighting and appliance changes met the Energy Star target, and then all the changes combined met the Energy Star and Zero Energy Ready Homes target. The tankless water heater had the single largest effect, which again, I was pretty surprised about that. I guess it is a pretty big improvement over the 0.62 efficiency gas water heater that was there to begin with, but that I was really surprised about. It seems like a good bang for the buck. But honestly, lighting is probably the most cost-effective improvement if you're not already using 100% LEDs. It doesn't cost much to upgrade, and that dropped the ERI 2 points, which is significant. All right, so that is the end of my presentation. Now we can take some questions.
Hey, yeah, thank you so much, Eric. And before we get to those questions. Just real quick here. We just as a reminder, this session is being recorded, and you can rewatch this session anytime. Share it with your friends, your colleagues if you want. Just head over to our YouTube channel, and you can get an instant update when that's available. And or you can subscribe now and get that update at a later time. For those of you watching this in the future, not right now, but on demand, head over to the quiz, take the quiz, get an 80% passing rate, and you will receive your continuing ed certificates. For those of you here today watching this session, you just need to make sure you were here the entire time, logged in appropriately, and then check your spam over the next couple days for certs at gutenbergcerts.com. And as always, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our sponsors, especially our top tier sponsors, Rheem and Mitsubishi, who make air source heat pump systems that are going to help, in most cases, as you saw, improve your energy rating index and make the home more comfortable, healthier, and more sustainable. So yes, Eric, let's get into some of the questions that came up here. And just going back to existing housing as a reminder, you had mentioned that there actually is a way to sort of model out a performance improvement plan with a program like this. Is that correct? I heard that correctly?
Correct, yeah.
Okay. I know some tools like the Department of Energy's Home Energy Score, which is really made for existing homes, just to be honest, kind of give you some artificial intelligent estimations on what you should do. Do you know if that happens with something like this, or is this really you kind of got to make guesses like you were showing us?
Yeah, so currently in with our software tool at least, you do kind of have to make guesses. We are working on something that would kind of be some baseline assumptions based on the year the house was built. So you could input some basic stuff, some basic measurements, some basic equipment stuff, and then we'd make assumptions about the rest. And so you can do minimal changes and minimal modeling to get to some analysis and figure out what improvements are best.
And I really like how you took us through that whole modeling example. It would be so great to see raters, energy verifiers during design meetings, really sitting down with the client and making that kind of modeling sort of thing you went through in real time, right? With the experts around the table who can tell you, oh, it's going to cost you this much, like kind of what we do for lead design charrettes, but focused on the energy aspects of that. I assume this is something that is set up in a way that can give feedback maybe in a meeting, or is it something that has to crunch data for hours, so you really couldn't do that in real time with somebody?
No, I mean each change, each analysis probably takes 30 seconds, 48. It also depends how many analyses you're running. If you're running, standard ERI, Energy Star, Zero Energy Ready, obviously it's gonna, compound. But yeah, for a single analysis, maybe 30 seconds for each new analysis, and that's whether or not you change 10 things or one thing. It's really the same time, so you really can do it in real time.
Yeah. Now, what if someone is an architect or a designer or design build, or even a do-it-yourself homeowner? We got a lot of fantastic do-it-yourself homeowners on here who want to educate themselves and take control of their own project, which is fantastic. I know a lot of these tools, we kind of say they're sort of these mystery boxes, these black boxes that are really only allowed for the verifiers and raters. Are there any opportunities for them to sort of get access to something that actually is meaningful? I know you mentioned the open source NREL, which I guess is great. But something if they wanted to access a little bit more to kind of see how their design is coming out before, and again, we're not encourage anyone to not work with a verifier. You can't self-certify your homes by any means, but at least be able to kind of have an informed decision to send it off and then hire a verifier,
Sure.
a rater, to do this. Because a lot of times we've heard from architects before, like, oh, we put this whole nice thought into it, we zip it off to the verifier, and then they get it all wrong. And
Yeah.
so, you know, maybe there's a communication breakdown, and that's just because the architect doesn't have that access. So is there anything like that? Is that being discussed? Like, what kind of opportunities are there?
So at House Raider, at least, you know, we're open to working with builders and architects and other groups to do that. You know, we're open to that. I know the ResNet software, I believe you have to be a certified rater going through a provider to get access to those. I'm not sure if they have other things available for builders and architects. But yeah, House Raider, we're definitely open to working with builders and architects to do that initial analysis and kind of do some of that themselves before they ship it off to the rater.
Yeah. Yeah, great. Well, I appreciate that. And um, uh, some other questions that were coming in here. I think there was just some clarifications on the dates, the permitting dates for DOE zero energy ready. That's one new thing that I learned that I was surprised about on a recent project was it sounds like some of those ERI targets change based on when the project actually is permitted, but they usually try to give you advance notice of that, correct?
Yeah, I yes, I believe so. And with the 45L dates, I'm pretty sure that's what I'm not 100. I believe those are the dates. That's what I've heard. I'm not. I could be wrong. If I am, please correct me. But yes, I do believe that's those are the dates they're going off of.
Mhm. Yeah. So everyone can check those. It was just there were some people clarifying that. Now, interesting, a comment came in about carbon dioxide. So somebody was saying, oh, this measures carbon dioxide in my house, because we talk about at GHI under the health pillar quite often the importance of reducing carbon dioxide indoors for various health reasons. But when you were talking about CO2, again, you're talking about the carbon emissions index that the house generates really more at the utility level. So can
Yeah.
you just talk a little bit new about this? Because this is fairly new,
Mhm.
this carbon index kind of thing.
Yeah. So yeah, the carbon index went into effect with Addendum D of the 301 2019. I believe it was back in 2021, something like that. And what it does is it compares it's like the energy rating index in that it's an index and it compares the actual house to a reference home. The CO2 index reference home is all electric, I believe. Connor, you might know this better
Yeah,
than me.
it is all electric.
It's all electric, so you do get penalized quite a bit for using gas. Most dual fuel homes that I've seen are coming in over 100 in the index. Only all electric is coming in under that. But yes, the CO2 index is looking at more like the utility level emissions of the house, and it kind of the same process as the 301. You have your reference home, analyze that with it replaces equipment, things like that, and then compares the actual house against that home to determine your index.
Well, just a reminder, it is now 1 Eastern. We have a few more questions, so we're going to stick around if you're okay with that, Eric, and
Absolutely.
just keep having some conversation. For those who are listening to this on demand or live anyway, and have to go, you're more than welcome to leave as long as you've been here for your CEU hour, and you can catch the rest of it on demand. We'll have the recording up. But otherwise, and we didn't want to tell you you had to stay, and so you can get going. Otherwise, we're going to keep having a little more conversation. So um, let's keep talking. So another, I think what was really interesting is just some of the commentary here about being surprised about how something didn't do how something didn't change the ERI very much, or it did change the ERI very much. I was actually very surprised to see that the targets changed
Mhm.
for certain things like Energy Star, like DOE Zero Energy Ready. And of course, if you're going for LEED, and an Energy Star target changes, well, then that changes your lead target. And if
Mm.
you're going for passive house, at least the US version, and the ERI target changes on DOE's or Energy Ready, that changes, in theory, your passive house target, though in that one, you got a long more way to go. So I
Yeah.
wouldn't think too much about that. And so that was surprising to me. So I wanted to point that out. But I think kind of what I'm, it's interesting because we keep having these conversations, and people always tell me, I wish there was the perfect energy modeling tool out there, because I don't agree with the change that was made. Hey, you just dropped the ACH from 3 to 2, and it didn't give me the score that I wanted, right? Like, it should have gave me the score I wanted. I'm selling a product that insulates better, so it should give better scores. And so I am constantly berated by people about how they don't like energy rating systems because it didn't tell them the information they needed. Maybe it hurt a client's feelings
Yeah.
sometimes. And that's, I think, just what's really important about these tools. They're third-party verified accredited programs that sort of have this information in one place, so we all have a reference starting point. But if I understand correctly, because they're an ANSI process, if people have a complaint, they have a pathway by which to have their opinion voiced. Is that correct?
Yeah, you can always they always publish their the standards for comments before they're approved and released. So yes, you can and I can throw a link out here. You can look at the standards and the changes that they're making, which they highlight when they're making changes, what they're changing, and voice your feedback on what you think on that. And before they're approved, so there's a board, a committee, the Standards Development Committee that reviews this, and it has various stakeholders. Dean Gamble from the EPA. There's different people representing software and builders and manufacturers and trades and things like that on this committee, and it has to get approval from majority before it's approved. So you do have different stakeholders who take part in that, and review the comments and consider that. And yeah, you're absolutely right. There's with any energy rating index, any energy modeling, there's no perfect system out there. It's what kind of question you're trying to answer, and there are always trade-offs between getting more specific and requiring more inputs and fewer inputs, and yeah, nothing's perfect, and it is complicated. It's a complicated process, but it's something.
Yeah, yeah. And Connor, maybe I can bring you in on this question. But the question is, let's say, and I would assume in most cases we're talking about a verifier rater here, or someone who wants to become one, maybe a professional as well. But what does training look like to understand how to use this tool or implement it?
Yeah, that's a fun one. So to do that, you're gonna have to work with one of the approved EPA recognized, DOE recognized HCOs. So there's either RESNET or BSI. With RESNET, you are required to go through an accredited training provider, which is a third-party company. You have to go through a specific training process for them, and there's like I think three. If you're looking at just the modeler certification and not the full HERS rater certification, there's three like test models that you have to do. And then, that's more or less it, right? You can get certified, and then, you just have recertification requirements after that. On BSI side, for the equivalent level certification, we have 10 case study requirements that you have to go through, as well as a series of educational a series of workshops about different things that people actually understand, not just here's a software tool, how to use it, a little bit more of the science, and hey, you're going to get field inspection data from someone. How do we interpret what this picture means of crappily installed insulation? And so it varies depending on the organization that you're going through. But under ResNet, you go through a training provider. With BSI, you just are working with BSI directly. You don't have to go through a middleman or anything like that.
Eric, any follow-up on that? And let's say you're not trying to become a rater or verifier, just trying to understand really more how the tool works. Maybe you want to use it for design or construction.
Sure. Yeah, we use our tool for our utility programs and kind of, custom reference homes and things like that to determine different types of savings we're looking for. And it is available to other people in different capacities, as we mentioned, builders and architects are willing to work with them, utility program implementers and utilities, whoever it may be. It's out there, and we're willing to work with people.
And is that like a personalized training, or is there like a formal training on that, or?
Um, it kind of, so we have some training resources out there, but it kind of depends on how you're going to be using it. It's there are a lot of different features that some people use, other people's don't, depending on the role that you're looking to perform with the software. So it kind of depends on what you're looking to do.
And you just mentioned utility usage and all that. So just to go back, some of the outputs of this, there's a lot of other informational outputs from this tool other than that, typically energy rating index tools generate. You mentioned some of them, but just again to clarify, you can look at estimating, right, operational costs, energy use per square foot. I mean, are those things available as outputs?
Yeah, absolutely. You're able to input, utility cost, custom utility rates based on where you're at and what utility it would be serving the territory. And as far as outputs, yeah, we have with our tool, I don't know everything Ecotrope returns. I know they return a lot, but Open Studio gives you all kinds of output. It breaks down, fuel usage, not just by category heating, cooling, but by, backup heat pump heating and fans and motors versus, actual heating fuel usage. And it breaks it down on a very granular level, peak loads, gas and electric, all kinds of stuff. The calculated loads for the different components of the, what type of heating gain is coming from the ceiling versus the walls versus the floors.
That was gonna be my next question. So you can kind of see maybe where energy is being used the most, and then say, oh, let's come up with a plan there.
Yep.
Yeah.
Yeah.
Great. Yeah, because it's like something where you did it, it seemed more like, oh, you had a plan, you were testing things.
Sure.
But I wondered, like, if someone just put in sort of the worst performing building, would it maybe tell you, oh, you're losing heat here?
Yep.
Do better windows, right?
Yeah.
Yeah.
Yep.
Yeah, that's great. What was my other question that came in here? Oh, and then yeah, on the outputting, you had mentioned ESG, environmental social governance. People say ESG, it's dead, it doesn't work. I don't know what, if that's true or not. But anyway, what were those outputs again that typically investors are looking for? Is it like the ERI score that they're looking for? Or it sounded like they were like emissions outputs.
Both. So I looked at a couple different builders in their ESG reports that they put out, and yeah, typically they'll report their average ERI scores over the years. They'll report their CO2 emissions for their homes, their sulfur dioxide, nitrogen oxide emissions that they're getting from these models for their projects.
Okay.
Among other things, and sometimes they report their own energy usage for their offices and their headquarters and their
right, they're
field
mixing
stuff.
it in
Yeah,
with that for their total corporate rating. So
yeah.
Yeah, that makes sense. I was trying to see if there were any other specific questions here that we missed, but yeah, I don't really think so. So Eric, where can, just as before we wrap up, where can people go to learn more, to contact you, or yeah, maybe get involved if they want to?
Sure. So my email's up here on the screen. Feel free to email me if you have any questions or are interested in anything I talked about. In the slides that you sent out, I don't know if the links work. If they don't, I can send out or you can send out the presentation itself. Find the people having the slides. With those links, so you can look at, BSI, you can look at ResNet, you can look at the different software tools that are available. their websites. You can find all the different codes, the IECC codes, the standards, the Energy Star pages, to learn more about all those programs and certifications. Yeah.
Great. Well, thank you again so much, Eric. And also a special thanks to Connor Dillon, who introduced us as well, and also a little special guest helping out on the show from Building Science Institute. So thank you, Connor. Thank you, Eric, with House Raider. And thank you all for joining us. And we will catch you all next week. So take care. Be well. Bye.
Thanks, Brett, and thanks everyone for your time.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.